Okay, so, well, thank you. My name is Mitch Coward. I'm the Senior Sales and Marketing Strategy Consultant for Caterpillar's Safety Technology. And for the next 40 minutes or so, we're going to be talking about innovations in construction safety. And Dylan, if you click the next slide, if we think of safety as a river, then really what we're all after, click, are these downstream results. It's fewer injuries, lower insurance claims, fewer fatalities, reduced incidents, and overall stronger safety culture. But just demanding employees produce those things, as we know, is impossible. And so what we have to do is focus upstream. And if you click there for me, Dylan, what we're looking for is up in the upper left-hand corner to get as far upstream as we can around hazard identification and correction, as well as near-miss reporting and incident investigation, training. Ultimately, all of that adds up to behavior change. Click. And when we talk to supervisors in the construction industry, they all tell us that they're under constant pressure to keep productivity up, keep costs down, and keep their people safe. Click. But to that end, they're seeking new technologies. They're investing in big data analytics, the Internet of Things, artificial intelligence, augmented reality. Some companies are already using unmanned aerial vehicles or drones to fly their sites. Some are already using remote controlled equipment. Some have non-line of sight remote controlled stations where they're operating multiple pieces of equipment remotely. And undoubtedly, in boardrooms across the world, there are executives imagining positive futures with fully autonomous equipment. In fact, the group that I report to is called Automation and Autonomy. But until that future becomes a reality, we believe companies like yours are heavily invested in the most sophisticated technology that's available on the planet today. And that's a network of massively parallel electrochemical digital computers that run on glycogen and oxygen. And it's this integrated network, click, of biological computers, that is your people, who make all of your critical operational decisions to control all of your plant and operate all your equipment. It's people and their beliefs and values and decisions and ultimately behaviors that create workplace safety. And we know from our own experience that we expect workers to show up and maximize the power of their biological computer, but we know that many struggle to maintain attention, perception, and situational awareness. And so what we're after, a couple of clicks there, Dylan, what we're after is to create a work zone, to help our customers create a work zone where people, click, are safe, both physically and, one more click, psychologically, that supplement human factors, mitigate risk, and generate data to inform continuous improvement and drive behavior change. I'm going to go over that one more time because this is really the crux of what we're after. We're here to create a work zone where people are safe both physically and psychologically, that supplement human factors, mitigate risk, and generate data to inform continuous improvement and drive behavior change. The emphasis on behavior change. Click. So if we think about that statement, and we might ask ourselves, well, what are the human factors that are frustrating our ability to have a safe work site? And there are things like operator knowledge, attention, vigilance, decision-making, situational awareness, human perception, and risk assessment and avoidance. Today, click, we're going to focus on three of these. Specifically attention, situational awareness, and perception. And I'm going to review some of the technologies that Caterpillar has to offer that help supplement those human factors of attention, situational awareness, and perception, generate data to inform continuous improvement, and drive behavior change. So let's begin with operator attention. Attention is the key to a safe work site. It's a cognitive process that's important to virtually every activity construction workers perform. Without it, we can't selectively process information and discriminate the important from the unimportant noise that's continually surrounding us. It's one of the most studied processes in cognitive psychology and neuroscience, and it's considered to be the gateway to perception and situational awareness. So if you would click for me, Dylan, because this is going to be the first Caterpillar presentation that customers have seen that has a photograph of Van Halen and M&Ms. You might be wondering, what the heck does that have to do with safety? Well, back in the 80s, Van Halen had one of the most exciting concert shows in rock and roll. Lots of lights, sound, and pyrotechnics. And because of all that energy, there was a need to make sure that the stage was safe and powerful enough to power their stage show. And so they would contract with concert promoters with a very thick rider, 100 pages of details. Things like there must be, 27 15 amp breakers 16 feet apart, lots of details that were specified in the contract. And embedded right in the middle of all those details was a clause that said something like, "And there shall be no brown M&Ms backstage." If any M&Ms or brown M&Ms are found backstage, the band has the right to cancel the show, and the concert promoter must still pay the band in full. So there was a lot of liability for the concert promoter. This is a true story, by the way. It's in David Lee Roth's book, and I've also seen interviews with him, and he says that this is what they did to ensure the safety of the audience, the band members, and the crew. Because if they went backstage upon arrival at the concert venue and they saw a bowl of M&Ms that had brown M&Ms, they knew that the promoter had not read the details of the contract, and therefore they needed to check every little thing to make sure that the show could go on safely. Well, why am I telling you about this? Click for me, if you would, Dylan, because the first technology I want to share with you is a simple one. It's a seatbelt reminder. Click. It has an indicator in the cab to tell operators and remind them to buckle their seatbelt, because click, after all, the best practice is to buckle your seatbelt. Click, because OSHA data reveals that any operator in a rollover incident that is in a machine with rollover protection and a seatbelt is sure to live. Their data says 0 fatalities occur when you combine a seatbelt with rollover protection. Click. And that's important. So we want operators to wear their seatbelt. But the M&M part of this, the really valuable part, is the external beacon that goes on top of the cab of the machine, so that a superintendent can look out on a job site and at a glance, just like Van Halen walking into the backstage rooms with the bowl of M&Ms, and they can see, are the operators paying attention to the very first step of safety? If their seatbelt isn't buckled, then we must ask ourselves, what other details is the operator overlooking? Does the machine have oil in it? Does it have coolant? Are they overriding certain other best practices? And so that light on the external part of the cab that is indicating if the machine is in a safe state or not becomes like that bowl of M&Ms for Van Halen, allowing you to see if the operator is paying attention at a glance. If you would click for me, Dylan, because we're going to move on from this. And well, just as a reminder, click 2 or 3 times here for me, because Just implementing the seatbelt reminder can help us get upstream, far upstream, to give us an indication if our employees are paying attention to those little details. It's that attention to detail that helps create safety. And so it becomes an important upstream behavior on that safety river. If you click for me. Moving on, we're going to continue to talk about operator attention. Because more than 15 years ago, Caterpillar ventured into this area to help our customers, specifically in the mining industry, address lapses in attention. So we use the driver safety system. It has an in-cab camera that focuses on the operator's head and face. And when it detects an operator suffering a lapse in attention, it vibrates the seat with a vigorous vibration motor, sounds an audible alarm, and nudges the operator back to attention. Click. Now, those were actors, but this next video was actually captured by, one more click, by Caterpillar's driver safety system. And you can see here that the operator is suffering a lapse, and then the vibration motor nudges him back to attention. Also, distracted driving can cause operators to not pay attention, and our driver safety system focuses on that as well. Click. When the system detects a lapse in operator attention, click, three things happen. The first one is we intervene. We shake the seat, we sound the alarm, and we nudge the operator back to attention. Click. The second thing we do is we save the data. There's accelerometer data, GPS data, as well as video data in the cab and through the front windscreen. So we know the context in which an incident is taking place. And when those data are captured, they're compressed into an encrypted data file, very secure, and transmitted to Caterpillar's 24/7 monitoring center. Click. Where we have trained safety advisors who review every one of these event files as they come into our monitoring center in Peoria. We categorize, classify, verify each one of these, looking at the telematics. We know where, when, how far, how fast. We can see this video clip and understand that this operator isn't just singing his favorite Van Halen tune, but he's actually struggling to stay awake. And that becomes an upstream early indicator. These big yawns, closing of eyes for extended periods of time becomes an upstream early indicator that gives our customers the power to intervene before something downstream more serious happens. One of the ways that we do this is we provide customers with an opportunity to measure this risk on their job site. Click through a bunch of times here for me, Dylan, because there's about 10 different clicks, and I'll just speak to them. We offer customers a risk assessment that allows them to understand baseline data to capture the current state of attention risk on their job site. And then we actively engage the workers, turning on the alarms and alerts and measuring the change in behavior. And then we help our customers create an intervention plan. And then we pilot that plan over the last phase of the assessment to test how much behavior change we get. If you would, click to the next slide. And I'm going to share with you some data that we have captured from one of these risk assessments. And one more slide for me. So this first table is showing the amount of distraction risk. Maybe it's taken a moment to update, but the amount of distraction risk on a job site. There you go. Click for me one more time. And you can see that this customer engaged. Okay, this customer engaged in a risk assessment. You can see the three phases. Each phase was 30 days long, and they had 524 distraction events in phase one. Oh my gosh, 524 in 30 days on just 5 trucks. And half of those were cell phone events. And this company had a zero tolerance policy for cell phones. Use a cell phone, lose your job. There were over 250 cell phone events in 30 days on just 5 trucks. They drove 12 miles distracted, and they wanted to fire employees. And we asked them, just trust the process and its ability to inspire behavior change. And you can see that over the next 3 phases, the number of distraction events reduced by 99%. If you would click for me, because that is distraction. But what about fatigue events? Well, you can see again in phase 1, we had 61 fatigue events, and they drove about 13 miles, 12.9 miles asleep at the wheel with their eyes closed. And you might ask yourself, well, man, how do you get people to fall asleep less often at the wheel when they're in this boring application, this boring job of, say, driving a haul truck or driving a road over the, driving a truck over the road? And the answer is you have to inspire them somehow to change their behavior at home, where we don't really have any authority of what they do. So is this technology capable to inspire that kind of behavior change when they're not at work? We'll look at phases 2 and 3, and you can see that it went from 61 fatigue events down to 2 for a total of 93% reduction in fatigue events. That's a significant behavior change. And one more click for me, Dylan, because the next slide becomes really compelling as we compare the driver safety system events to VisionLink events, specifically the operator-induced events. Those VisionLink events captured by all the sensors on the machine that would be impacted by an operator, things like driving with your foot on the brake, hot brakes, ground speed with the dump body up in the air, overriding the engine shutdown procedure, driving with the low oil light on, driving with low engine coolant light on, and a whole host of other operator-induced events, abusive shifting. And as you see in this table, at the same time that we achieved that significant reduction, that significant change in behavior related to fatigue and distracted driving, we also achieved an 88% reduction in the number of operator-induced VisionLink events. That's significant behavior change in just 90 days. And while we can't guarantee that kind of result, it is an interesting correlation that as operators came to work better rested, more alert, more attentive, that they paid closer attention to the way they were operating the equipment and achieved better results in terms of that. So if you would click the next slide for me, because we're going to think about that again in terms of that safety river. You're looking for fewer injuries, fewer fatalities, lower insurance claims, stronger safety culture, higher attention to detail, even operating the machine better. All those downstream results, we got that from driver safety system by focusing upstream on hazard identification and correction, near miss reporting, as well as training operators on how to improve their sleep quality and quantity at home. Now, let's move on to the next operator human factor, and that's situational awareness. If you would click for me one more time, because local situational awareness can include the perception of workers on foot, or the perception of light vehicles or terrain features, gravel piles or trees or other objects in the immediate area. And we need to give operators the ability to improve their human factor of situational awareness. Click. And so Caterpillar offers Detect with surround cameras. Click. And that enables us to install 4 cameras. It's an aftermarket solution. You can put it on any kind of equipment, including non-Cat machines. And it gives an operator the power to see all the way around the machine in about 360 degrees. And much like if you have a newer vehicle today, you can have that kind of surround vision. We're able to offer that to you in an aftermarket solution. So even if you have an older machine or you have a non-cat machine, you can go to your cat dealer and order surround camera. Click for me one more time. If you have a medium wheel loader and you'd like to be able to detect objects in the blind spot of that wheel loader, you can purchase from your dealer a retrofit kit called Detect with Object Detection. And this is a radar-based solution that provides an audible and visual alert inside the cab when the radar detects, click, an object in the blind spot. And so that retrofit kit looks like this, and it's available for a specific range of medium wheel loaders. So if that's something you might be interested in, your representative at Foley can help you identify whether or not this is a solution that would fit on your medium wheel loader. Click for me one more time, because we're going to talk about operator perception. That is important to talk about. And just for a minute, if you'd like, allow me to explain that the constructive nature of human perception refers to the idea that we don't really perceive the world as it actually is, but rather our visual cortex constructs a reality based on our prior knowledge, our expectations, and assumptions. Human perception is influenced by many factors, such as our attention, which we've been talking about, our motivations, emotions, our mood, the culture that we're working in or living in, and the context that we're trying to work or be in. Our perception isn't always accurate or reliable, and it can be distorted by illusions or biases. Just ask any baseball fan whether or not the ump ever needs glasses, right? We don't always see reality the same way when it comes to referees. Or even fatigue or cognitive workloads can distort our perception. And so to supplement the human factor of perception, Caterpillar's created an aftermarket solution that we call Detect with Smart Camera. Click. Detect with Smart Camera is a system that's based on artificial intelligence. It's a computer vision-based system that detects people in the danger zone around earth-moving equipment. I'm going to emphasize that one more time. It uses a computer vision system that can detect when a human being, your son, your father, if you're in a family business, as I once was, where my father-in-law might be operating the equipment and I was on the ground, and he might want to, some days he might want to run over me, but let's assume that he really didn't. And a system like this would warn him if I was in the danger zone behind the equipment. So if you would, let me click and just let me explain for a moment how this kind of technology works. It's really based on machine learning, which is a branch of artificial intelligence. I know that's a popular phrase that people throw around a lot, but this is a computer science that focuses on the use of data and algorithms to imitate the way that humans learn, and then gradually improving its accuracy. Click. And I'm going to explain a little bit how we do that. You can see in this photograph that there's a person sitting at a computer station there looking at a photo or video, and they're practicing an area of machine learning called data labeling. And what they're doing is sitting at a computer terminal and drawing boxes around the objects that are in this video, and using some special software, and then typing in or tagging it. This is a person on a scooter. This is two people on a scooter. This is a scooter following behind a car. And they're teaching this computer program what scooters and people on scooters look like. So if you would click for me one more time. The other concept I want to introduce is that of a convolutional neural network. Now, this is a class of deep learning model that attempts to pattern itself on the human brain or the way the human brain works. It's widely used in computer vision and image recognition. So click one more time for me, Dylan. A convolutional neural network can be deployed to detect and recognize objects, or in this case, people on a construction site in real time. So by training a convolutional neural network on a large data set of images, which we've done, which we captured by capturing thousands of hours, tens of thousands of hours of construction job site video from earth moving equipment and on different kind of job site settings. And then we trained it to identify construction workers on job sites who are in high risk proximity to the machine. Click. So that we built our own convolutional neural network that was focused on identifying human beings on a construction site. And that convolutional neural network runs on this system that we call the smart camera. It's kind of an elegant system in that it's primarily three components: a smart camera that mounts in the blind spot of your equipment, a touchscreen computer inside the cab, and then this wiring harness. Today, this is an aftermarket solution that can be installed in old CAT machines, current CAT machines, new ones, or even non-CAT machines from other manufacturers. Your representative at Foley can help you if you're interested in keeping your employees safer. They can help you get the smart camera solution. And let me tell you, if you would click for me, Dylan, because I just want to explain how this is so much better than a backup alarm. Backup alarms are so ubiquitous. That's all you hear if you're a construction worker. When you lay down at night and try to get to sleep, you're hearing backup alarms in your head. Those of you who work around them all day know what I'm talking about. What's special and really great about the CAT smart camera system is that it's quiet. It's quiet until a collision potential emerges. And only then does it notify the operator in the cab, as well as an external alarm to warn those workers on the ground. Otherwise, it's quiet. And it has different alarms depending on how imminent the collision potential is. So as the danger increases, so does the alarm change. Click for me to that slide, and let's see if the audio will work on this. So here's the example. The machine is backing up, and if he doesn't change his speed or trajectory, the collision potential will escalate and begin to notify him. No, we can't hear the audio, but this audio would be an intermittent loud beeping in the cab. And then if he doesn't change, put on the brakes or change, then the alert kind of screams at both the operator on the ground and the operator in the cab to say, hey, danger, you need to stop now. And so this becomes actionable information that we've actually seen change the behavior of workers both in the cab and on the ground. If you would click for me one more time, Dylan, because this solution can be installed on a wide variety of machines. The camera just needs to be between 1 meter or 3 feet and 15 feet high. So as long as it's in that range of 3 feet to 15 feet high, it can go on almost anything, 12 volt or 24 volt, mixed fleet solution, it doesn't matter. And Foley can help you with that. We have done some assessments with this solution. If you click the slide for me, this was a short study that we did, 2 weeks long. And we did week 1 with alarms off, a silent measurement capturing data of the current state of the risk of human equipment interactions. And then a second week where all the alarms and alerts were on to see if we couldn't measure behavior change. Click. And what we found is that when the machine was in reverse gear and moving, so the parking brake was off, the machine was in reverse, we achieved a 67% reduction in critical zone interactions. So you can see in that those red bars there on the far left, the critical zone is 8 meters by 8 meters. so about 24 feet, and pretty close depending on how fast the machine is moving. And we were able to reduce, using the smart camera system, the number of critical zone interactions by 67%. If you would, click twice for me, Dylan, so that we can, again, just remind ourselves of this safety river. What we're trying to get is fewer injuries, fewer fatalities, lower insurance claims, reduced incidents, a stronger safety culture, and smart camera produced in just 2 weeks a 67% reduction in those kinds of behaviors, and thus helping us get those downstream outcomes that we're looking for. So click for me one more time. Just as a reminder, what we've been talking about are human factors. We've been talking about things like operator attention, perception, situational awareness, and ultimately, what many customers want to know is, Mitch, this is really cool, but will it stop the machine? And the answer is, today, as we opened up today's presentation, we said that the most sophisticated technology that was available on your job site today was your people. That biological computer in the skull of your workers is the most reliable collision mitigation system on a dynamic construction job site. Given that they are a typical human being in a typical state of physical and mental and psychological fitness for duty, and supplemented with technology, the kinds of supplemental technology that we shared with you today, whereby the operator is given the right information at just the right time, we're confident they'll do the right thing and stop the machine. Click for me one more time, Dylan. And we're about to wrap up, because Caterpillar is on the developmental path to the future. In the very near future, and I mean within the next 18 months, machines will be made safe by an Internet of Things technology, global navigation satellite systems, computer vision systems, convolutional neural networks like we talked about today, machine learning, artificial intelligence, sensor fusion mitigation techniques, where we begin to blend both smart camera, computer vision systems with radars to fuse those two together to create a mitigation system. But today, the safest operation of machines is still dependent on the human operator. Click. And therefore, we must help our customers create a work zone where people are safe, both physically and psychologically, that supplement human factors, mitigate risk, and generate data to inform continuous improvement and drive behavior change. And so with that, we're right at, I have 40 minutes. And so I have a short 1-minute video here. You can't hear the audio, but it's basically explaining that for over 100 years, Caterpillar has been helping our customers build a better world, and to do so safely. And we do that not only in the development and design of safety features integrated into our machines, but also with consulting services like Caterpillar Safety Services, where we help drive or support customers. Some of the largest construction companies in the world use Caterpillar Safety Services to help them transform their safety culture, develop safety leaders, and manage continuous improvement. But also remote controlled technologies like the ones I've been sharing with you. We have the smart camera that we've been talking about, where you can identify people in the danger zone, the surround camera system that gives you a 360-degree view around the machine. Also, I think it's the seatbelt reminder system is next. So just as a reminder, that's like that bowl of M&Ms in the back room behind a Van Halen concert. And then finally, if you need to keep the operator safe, who's working in hazardous conditions or hazardous environment, we have CAT Command, which enables you to get the worker completely out of the cab so that he can operate machines totally remotely from a safe location outside of the machine. And so we've been serious about safety for 100 years, and we're implementing some of the very latest technological advancements to help you keep your workers safe. Foley hosted today's meeting, and you can count on them to help you as a type of consulting partner to help you decide which one of these solutions best fit your need.